from storage to network. We have the next presentation from Mellanox, who is also our sponsor. And so I call Avi Alkobi here. He was with us yesterday in Milan. He did his presentation there. This presentation too is very interesting, so I hope you enjoy it.
Hello everybody. My name is Avi. I'm Director of Ethernet Switching in EMEA for Mellanox Technologies. Very happy to be here. As I said yesterday, I really would like to do this presentation in Italian, but my Italian is very piccolo, so I will stick with English. We're going to talk today about open source in networking. So typically open source is more considered on the server side. It's compute and storage. But guess what? Actually, in the last few years, it's also very popular in the networking domain, which is dominated by vendors that were very lucky, right? So if you remember many years ago, also on the server side, if you wanted to add a feature, if you wanted to change something in your application, you were dependent on the vendor on the blog, HP or Dell, to actually provide you the solution for that. And today it's really not relevant, right? You are actually choosing your own hardware, putting the operating system, if it's Linux, typically Linux based, and installing your application. And this is basically the way it works also for networking today. So to understand what I'm going through with this presentation, I do need to explain where I'm coming from. So as I said, I'm coming from a company called Mellanox. We're a public company listed on NASDAQ, $1.1 billion a year. So we're actually pretty successful. We are competing in two places. One of them is called InfiniBand. It's more for the HPC. I will not touch InfiniBand in this presentation. I'm going to focus on my part, which is Ethernet. On the Ethernet part, we're a small player, but very strong one, a very competitive one in the world where Cisco lives, Arista and Juniper. And we're kind of the small kid on the block that is kicking and trying to disturb. We have a headquarters in Israel and headquarters in Southern California. I'm here with Ricardo, a friend, country manager for Italy. And one thing that is very unique about Mellanox as a network vendor is that we are not touching only the switch or the router, we're actually doing something which is called end-to-end. We are a network vendor which is actually providing a solution of networking that starts from PCI to PCI. We are the largest and biggest vendor for NIC cards above 10 gigabit. We're dominating the market. Around 70% of the market is actually Mellanox. So we are starting from the NIC card, cable, switch, cable, NIC card, the entire pipeline. We own it. Having said that, we're not locking anything. If a customer wants to use a different cable, different NIC with our switch, different switch with our NIC, it will work. Everything is open source, everything is open. So why it's important? It's important because we have a different view on network. We're not focusing only on the network itself, which is considered a switch. When we are talking about network, we're looking at it a bit wider. And let's focus 1 second on the switch. When we are looking on the designs of the networks today, basically we're providing only 3 types of designs, that's all. The first one, it's called an MLAG based design. It's basically pure layer 2. MLAG is basically called VPC on other vendors, or MLAG. It means that we are taking a 1U switch, 32 ports, or pizza box switch, connecting it together. They are presented as one logical switch to the one that is connected below, and by that we are actually eliminating some issues that are related to layer 2, like spanning tree and other things. The nice thing about that, it's just layer 2, so from the server perspective, just connect your VLAN and it will work. But on the non-positive side, it means that you are limited on scale, because we just connected 2 switches on the spines, and basically if you have 32 ports, that will be the number of links that you can connect, and then you cannot do more than some amount of racks. The other option is a pure layer 3. It's very common in hyperscalers, the big companies that build data centers. They are doing only layer 3 down to the host. The host itself is running a protocol stack. If it's Quagga, FRR, Bird. What's the advantage here? Scale is unlimited. So if you're looking at the big boys, Facebook, Amazon, Microsoft, then doing layers and layers of switching. And it's all layer 3, down to the nose. And for, let's say, the market, small, medium business size, enterprise, also cloud, services, small market, EMEA, where I'm coming from, typically we're talking about this design, which is a combination of two, enjoying the layer 3 when it comes to scale, but on top of that, putting a VXLAN, which is an overlay infrastructure. And then you have the scale and also layer 2 connectivity to your service. So those are the 3 designs, only 3 designs that we're offering. They are called leaf spine designs. There are many names for them, by the way. It's leaf spine, it can be pay as you grow. Why? Because you can start small with one rack and then put another rack, and put more spines to connect them. It's called also web scale, east-west traffic, many names, but it's not very common to Mellanox. Any other vendor should at least try to recommend those designs. Those designs were actually led and decided by the network leaders of the market worldwide. So I will do a small quiz now. I will ask you who are those network leaders, who decides how the network will look like, okay? So I'll give you some options. The first one is Mellanox. Who thinks that Mellanox decides that? Nobody. Okay. Okay. Cisco. Oh, okay. You're wrong, by the way, but just think about it. Who thinks that Facebook? You're right. Facebook, Microsoft, Amazon. They actually decided that this is the way to go. And guess what? Also Cisco people will recommend that. I hope for them, by the way, because otherwise a 3-tier design Cisco-based in Microsoft, Azure, tomorrow will not work anymore. It's just not going to work. The way it's working is that those big guys are actually building the most demanding and biggest data center in the world by far. I really like Microsoft. I know they're not very open source oriented. I will give you a clue. I will show you that they're actually contributing a very important part in this. My open source idea for networking. Microsoft are buying a lot of switches from Mellanox. They are very good customers. They are buying a lot of switches that are growing exponentially. Data is exploding and they need to cope. They cannot do it unless they are working in this pay-as-you-grow leaf spine designs. They are the leaders, they are showing the way, and all other vendors like Mellanox are actually taking those ideas and bringing them to market. So everybody doing it, what is unique about Mellanox? One important thing to say is that we have our own silicon, our own ASIC that is running those switches. So when it comes to performance, how many bandwidth, low latency, buffers, and everything, things that are related to the ASIC itself, to the silicon, we have our own one and we can compare ourselves against Broadcom, Silicon, Trident, Tomahawk. We have our own one which is called Spectrum. It's very easy for us to compare ourselves against a bunch of other vendors because all of them, almost, are using the same ASIC, which is Broadcom-based ASIC, which is in the market. I will not touch the performance part. But let's agree here in this room that I said that we have very good performance and I can show you some benchmarks and so on. Another advantage which I showed you is the end-to-end part. We are unique in the way that we are not only doing switches, also NIC card. It means that when we are approaching a project, sometimes we offer a solution on the NIC as an offload and acceleration, not just focusing on the switch. Again, I will not touch this, but what I will touch is the Open Ethernet part, which we are contributing and supporting a lot. What does it mean, Open Ethernet? It means that we are not locking in any way. No feature fees, no cable lock, not anything. Also, we're not locking the operating system that is on top of our switch. So basically, you can buy a switch which is just bare metal. It's called white box or bright box. It basically means that you can use different operating systems. You choose the best one that is fitting your needs. And there is a list of operating systems that I will show you. Those operating systems will sit on top of a switch. This is the list of the switch that we're offering. Typical 32 ports of 100, typical top of rack which is 48 plus 8. Those are unique switches from Mellanox, half 19-inch switches, small switches, 16 ports of 100, 18 ports of 25 plus 4 ports of 100. All of this is running on Spectrum ASIC, which is unique to us. And Spectrum 2, which brings also 200 and 400 gigabit to the market. And this is how a block diagram of a switch looks like, no matter which switch it is, no matter which vendor. It will always look like that. You will have the ASIC, which is running, basically powering the switch, the the silicon, some fans, some CPU, memory of course. And on top of that you have software and application. The most famous application is a CLI, right? Or GUI or SMP, or there are many applications you can run. And if you open a bit the software, you will see that it will look like that again, always, no matter which switch in the world. ASIC again, and on top of that there is something which is called SDK. SDK is the vendor of the ASIC, for example Mellanox or Broadcom, that provides some API how to control the ASIC. If you want to set an MTU on the board, for example, in Mellanox we call it Mellanox set MTU. In Broadcom set MTU. And on top of that some software, right? So you have a port entity and a VLAN entity and a span tree entity, some software to control. And on top of that, a protocol stack. A protocol stack is responsible to run expanding BGP, ISIS, OSPF. Okay? And those components are actually running on top of some Linux. Okay? Remember that, there is always Linux. Right? So there is a Linux, some distribution of Linux, and it's interacting with the software. And now if we take this diagram and put it on the context of open source and not open source, so the red parts are not open source, right? And the green ones are. You see here on the left side, this is a typical operating system on the switch, the same block diagram, and it's all red. It means that basically, and it's like, you know, Onyx, which is our own operating system, or Nexus, or Junos, or EOS. It means that we are providing a box. It's a black box with a command line interface. It's running Linux inside, you will not see it. And basically you can do whatever we give you the option to do. Okay? And it's the same for, as I said, many other vendors. And if you open it a bit, you will see here what we call commercial NOS, as an example, Cumulus-Linux, if you heard about them, which basically it's a Linux on the switch. On Cumulus example, it's Debian and Jesse on the switch. But it's still commercial, it's Linux-based, it's license-based, but you can enjoy Linux as a native Linux. It means a lot when running Linux on the switch. But still you see it's not really open source. There are parts here that are red, which are really related to the vendor-specific hardware that is running below the Cumulus. And it's again license-based. And as an example for the most common open source today on the switch, there is Sonic. So Sonic started as Microsoft Sonic. Talk about that today, the fully open source community and controlled operating system. You see here now it's much more green. There's a small red part which is really related to the vendor, but all relevant vendors of ASICs today are supporting Sonic. So in the fact it's not really important. As I said, Onyx, our own operating system, closed operating system. Yeah, we are an ASIC vendor. We can give you an option actually to connect with the Linux beneath. You can actually install the Docker container on top of Onyx. Other vendors are also doing this kind of trick, but it doesn't mean that it's open. It's not. If you need some feature, if you need something, you know, we need to have a discussion. Cumulus, a disaggregated approach, means that if you remember the server part in the beginning, the same on the network. Choose your hardware. There's a list of hardware that support Cumulus. Choose the operating system. It can be Cumulus or other operating system. And choose your application. On top of that, it's Linux. And you can enjoy the power of Linux. License-based. Still, this is a block diagram. There is a red part which is not still open. Always trying to push upstream, but sometimes it's still closed. And so it's a commercial product. It doesn't mean that you need to live with the Linux. If you don't really like to use Linux, you can use it where you want to. It still comes with the CLI, it still comes with the GUI. Comes with all kind of enterprise kind of level package with it. And Sonic, as I said, the most common open source for network operating system. Again, Linux-based Debian Jesse operating system started at Microsoft. Microsoft are running Sonic on the Azure cloud, basically. And it's all on GitHub. Everything is open. This is a block diagram. As I said, there is a layer, a small layer here, which is not really wide because again, Sonic needs to actually communicate with the ASIC itself. So Microsoft came to Broadcom and said, look, I'm going to use your ASIC now. I'm going to buy 1,000 switches a month. You're happy, right? That's nice. But I also want to do another vendor. It's called the Mellanox. But I'm not going to implement twice Sonic. One for your ASIC and one for Mellanox ASIC. It will not make sense. So what we did, basically, we created a shim layer, which is called SAI, Switch Abstraction Interface. If If you remember, there is a layer which is called SDK, which is controlling the ASIC. So now above that there is SIDE. And let's call it not Mellanox ZMTU or Broadcom ZMTU, now we call it generic ZMTU. And each of the vendor will need to implement this API. And then a bunch of other ASIC vendor came in and also did that, of course, because they want to enjoy the benefit of the business. And this is basically what Sonic is. It's running the protocol stack, which is called FRR, Free Range Routing. It's a branch from another protocol stack, which is called Quad, which is a very, very strong protocol stack, Linux open source based. Cumulus, remember the guys, the commercial guys, they actually made it what it is today, and everybody are enjoying it. This is a snapshot from a blog of Azure. You see that Mellanox is the only vendor that is touching all the layers, the silicon platform, the application. This is the benefit of a vendor that's actually doing ASIC. So we have our own ASIC, we have our own operating system, we have our own applications. And this is kind of a picture of where are we contributing. So Mellanox is number 2 or 3 contributor of Sonic worldwide. I think it's after Microsoft and Alibaba, if I'm not mistaken. There are also many other contributors. The community is very, very big around Sonic. We are contributing features, we are testing features. You see this feature, it's called What Just Happened. What Just Happened, this is the name of the feature. It's one of the most advanced telemetry features in the world today. It was invented by Mellanox. It's derived from the ASIC, by the way. I will not touch that. It's a kind of big subject, but I would say that what's important here is that this logo, if you pay attention on the slides, I'm pretty sure you did, you saw this logo kind of exist also in Onyx, also in Cumulus, also in Sonic. What it means is that this advanced telemetry feature, and telemetry is very important in today's data center, very important. It's actually existing also in Sonic, also in open source. There are no compromises. If you decide to go with Sonic, it doesn't mean that you're losing power, you're losing visibility on your network, you're losing the telemetry features that you can get with closed operating system. You actually can get the features also with the open source option. Okay, so we'll touch it in one slide. I will say there is an even more open option, which is called Linux Switch. It means that you choose your own Linux, and you just install a driver. Yes, just doing with an e-card, right? You're placing an e-card, installing a driver, ifconfig, you see 2 ports, you can manage everything. So there is an option to do that also on the Switch. It's called Linux Switch. It's basically just a driver. On top of that, you need to build your protocol stack. Just download, apt-get FRR, install it. If you want to do ACL, TC Flower, if you want to activate your interfaces, IP-Link, just use Linux tools. It's called Linux Switch. And the feature set is very comprehensive. Basically, you can do everything because Linux today and FRR are very strong. Also networking when it comes to Linux infrastructure. So when it comes to features, you're all set. Why can we put open network operating system in production? So the answer is yes. Why? Because people are doing it already. I mentioned Microsoft, obviously, Alibaba, but also smaller company in Europe. Some which I cannot mention the name, in Russia, France, and other places. They're actually using Sonic today in production. And it comes also even with support. So Mellanox actually supports Sonic end-to-end, including the protocol stack, including the open source parts. And the feature, it's actually very rich. Why? Because the protocol stack, which I mentioned, which is called FRR, is today in a place where actually it's used in commercial operating system. So it's the same protocol stack, which is used by Cumulus, for example, is actually used in Sonic. In the end, I think it's also about economic and how to reduce cost and how to make sure you're getting the best performance of your network. So it's kind of a mix and match. You can go with the same OS all over, it can be closed, you can go with Sonic all over, you can also actually mix. Sometimes you will find Sonic not very fitting the top of rack, maybe if a feature is missing, maybe the behavior is not the one that you expected. So you can go maybe with Cumulus on top of rack. But on the spines, for example, Sonic can do everything. Obviously it will reduce capex because you just remove the cost of the operating system, at least from the spine here. And in general, it will reduce OpEx because open source means that you can use Ansible natively on Linux. DevOps is becoming very important. So becoming. It's a very popular networking operating system. Not sure if you have a few minutes or okay. So I'll try to do something. Let's see if it's going to work. This is my family. And let me see if we can make it work. After I will try. It's not going to be a full demo, it's a live demo, so it probably will not work. But let's try it. I'll take just 5 minutes and try to do that. Yeah, okay. Let's try to do that. Okay, so sorry, it's just a bit bigger, but basically this is a setup, it's a real setup. It's composed of a very simple setup, which is based on 2700, Mellanox 2700, 32 ports of 100 on the spines, 2100, which is a small switch, this 2100, 16 ports of 100. They are connected together in layer 3, BGP basically running as an underlay, and VXLAN overlay. Okay, so it's a VXLAN VPN implementation. Let's call it the most complex. It's actually not complex, it's very easy to configure. Configuration, a very common configuration on a network today. It's an overlay configuration. 2 servers are connected to the switch, are pretty strong servers, and you say PCI Gen 3, pretty strong ones, but not unique, okay, just out of the box connected with the NIC card, which is ConnectX-5. This is the Mellanox NIC card, 100 gigabit NIC card, okay? So, and the operating system that is running actually on top of the switches, this is Cumulus on the 2100, and Sonic on the spine switches, interacting together. Same protocol stack, FRR, running BGP VPN address family. So this is the VNI, it's called VNI 100. Basically, you see here, it's pretty small, but the IP here is on the same subnet as this IP. It's just like they're sitting on the same subnet, right? But remember, this is a VXLAN VPN environment, right? So it's actually layer 3, and on top of that, there is a tunnel between the 2 switches. Now what I want to do, what I want to show you that okay, this is the Linux switch. Sorry, the Cumulus, okay? This is the leaf, right? So you see it's connected to the 2 spines. Those are the 2 spines that are connected. This is what you call CLI of Cumulus, it's called NCLU. 2 spines are connected. This is the server that is connected to this leaf, and there is another leaf. It's just the same, just believe me, okay? And what I would like to do is just to show you the 2 servers and run a simple iPerf, okay? So this is the interface on one server, okay? And I'm going to just run iPerf. I think you already saw, because I ran it just before I started the presentation, the results. So it's just a simple iPerf, right? And it's reaching 93.6 gigabytes, right? So it's almost line rate. When people say 100, it's actually around 95, 97, right? So 93.6 gigabyte. That's a full line rate on a VXLAN VPN with Sonic, Cumulus. What I wanted to show you here is that, if you remember, I said you're not compromising on anything when you're going to open source. If you need to get performance, for example, you will get it. It doesn't matter if you're running Sonic or Cumulus or Onyx, which is our own operating system. There are some things in network which are not related to the software, which is performance. Performance is all about the AC, right? So, get the full performance, get the full speed out of your network, reduce cost by using open source. there is a large community. Use this community, use Mellanox, because we are there, we are strong there, and basically that's all. I want to thank you very much. If you have any questions.